Hello everyone, this is Neal Davis from Digital Cloud Training. In this video, I'm going to teach you about disaster recovery with AWS. So you're going to learn about some architectural patterns for how you can implement disaster recovery across multiple regions and with a variety of services. Now, this comes from our Solutions Architect Associate Bootcamp. Normally, I run this as a live session with our students where they get an opportunity to learn in a live classroom and then ask lots of questions. And we go straight after this session to build a multi-region DR solution in a hands-on lab that we all do together as a group. Now, in this case, I've pre-recorded this video so that you can get a glimpse into what we cover in our bootcamp and so that you can learn how to implement your own architectures on AWS with disaster recovery in mind. So I hope you enjoy this video. Let's get on with it. So what topics are we going to talk about today? Firstly, we're going to look at RPO and RTO. Really important to understand these. You'll see RPO and RTO referenced quite often in your working career. And we're then going to look at DR strategies, serverless DR architecture, and classic DR architecture. So firstly, let's look at the recovery point objective. Now this is the measurement of the amount of data that can be acceptably lost. Now, of course, normally most people don't want to lose any data, but there's always a cost associated with your systems such that if you want to reduce the amount of data loss to the smallest possible or to zero, then that's going to cost you more money than if you say, well, I'm okay with losing 60 minutes or 24 hours worth of data. So different price points. Now it's measured in seconds, minutes, or hours. An example would be that if your company determines that it's acceptable in a worst case scenario, if things fail, to lose 2 hours of data in a database, that would be a 2-hour RPO. That means that you would be taking backups every 2 hours. So for example, if your system were to fail 1 hour and 59 minutes after the last backup, that would be about the worst case scenario where you would lose the most data. So next we have recovery time objective. Now this is the measurement of the amount of time it takes to restore after a disaster event. So how long does it take to bring the systems back up again? This is again measured in seconds, minutes, or hours. So for example, if the IT department expects it to take 4 hours to get the applications online after a disaster, that would be an RTO of 4 hours. So let's have a look at this visually. So here we have a timeline running left to right, and a disaster occurs in the middle. Now the RPO is the measurement of how much data is lost. So if we had a 2-hour RPO and our systems worked as expected, that would mean that somewhere within 2 hours of the disaster event there should be a backup. Okay, so we set our RPO. Now looking sort of forwards, how long after the disaster occurs does it actually take to recover our systems? So maybe we have a 2-hour RPO, so we want to make sure we're running backups at least every 2 hours, and we have a 2-hour RTO. That means that we expect to be able to bring the applications back up again within 2 hours. Now, of course, that means that from this point to this point, the systems are not available and writing new data. So you've got a few hours potentially in that particular example of time where your application is not available or data is not being written. Now, let's look at what is achievable in terms of RPOs and RTOs. Now, of course, as I mentioned, you can achieve near zero or zero in some cases for both of these, but it's going to cost a lot of money. So it's about the techniques that we're using. So let's say if we want to get the RPO down to milliseconds to seconds, okay, a bit of a range there, then we would need synchronous replication. So where you're looking at milliseconds, that's a very low RPO, and that means that you're essentially synchronizing the data synchronously. So you've got to look at the systems that perform synchronous replication, such as database systems. Some file storage systems will do it as well. Then we've got seconds to minutes. That would be asynchronous replication. So with synchronous replication, what is happening is, let's say a database is replicating data to another database. Now the application writes to the main database. What happens is that transaction is not committed on the main database until it is also committed on the secondary database, the replica. So that would be synchronous replication. It actually waits for a response from that replica to say, yep, it's been written successfully, and then and only then is the transaction committed. Now with asynchronous replication, the main database would send the changes to the replica database, but it would not wait to get a response confirming that that data has been successfully written. So that is better from a performance perspective. Asynchronous is better for performance because your application is not having to wait as well for that for the application transaction to be committed to the database. Next, we've got minutes to hours. So techniques here, you might use snapshots, you might use cloud backup from your on-premises systems, or D2D is disk to disk, where we're copying data from one disk system to another one. Next, you've got hours to days. Obviously, this is a long time now. This is where potentially you have your backup data off-site. You've got traditional backups of some sort. They might be going to tape. They might be going to off-premises systems somewhere else. Now, the RPO is determined by how you take a backup of the data. Okay, how are you backing up? Synchronous replication just means every time a transaction is written to a database, it gets replicated somewhere else, and it has to be confirmed that it's written in that destination as well as the primary database before it's committed successfully. Asynchronous just means, one system is sending the change that's been written to it to another system. Could be a database, could be a file system, and it's not waiting for a response. And then snapshots is where you're just taking a copy of the data. You're literally saying, okay, well, here's some data on a disk. Let's copy it somewhere else. That's a snapshot. A snapshotting technology also does things like it only copies the delta changes since a previous snapshot. Okay, so various different techniques. So how you back up your data is the RPO. Then we've got RTOs, the recovery time objective. So here, if you want milliseconds to seconds, then you need fault tolerance. Now, fault tolerance simply means that if one component fails, it does not cause an outage of the system. So for example, you can have mirrored disks, it's called RAID 1, and with mirrored disks in a server, if one disk fails, the other one continues. Okay, so there's no outage whatsoever. It means you don't notice it at all from the application perspective. Now, fault tolerance can be quite expensive. It's difficult to implement for systems that are distanced from each other. It can be implemented more easily within a system, within a server, within the hardware or within the rack, but across distance, it becomes much more difficult. Next, with seconds to minutes of RTO, you're looking at high availability solutions, load balancing and auto scaling. So if one thing fails, that's okay, it will just fail over to another one. If an instance fails, then you'll auto scale and bring a new one up, that kind of thing. Next, we've got minutes to hours. So now this could be cross-site recovery in the cloud. So recovering to a new site. So perhaps an entire region goes down. Well, it could take a bit of time to now bring up that infrastructure in another region. Not necessarily, depends on how you built it, but it could do. And then automated recovery. So where you have some kind of scripts, some automation that's happening to bring systems up, but there may be a fair number of dependencies and systems and it takes a bit of time. Next, you've got hours to days. So here you're looking at things like cross-site recovery again, but not just cloud, on-premises as well, and manual recovery steps. So the RTO is determined by how quickly you can recover. Now, let's look at some examples with AWS databases of what you can expect in terms of RPOs and RTOs, or in some cases, the SLAs that AWS give you. So with RDS, we have a few different options. One is automated backups. With this, you have an RPO of about 5 minutes. The RTO is minutes to hours. They don't specify exactly, and it will depend very much. The RTO will depend on your database and how big your database is. This is single region, okay, so automated backups within a region. We then have manual snapshots. In this case, the RPO depends, so when are you taking the snapshot or how are you doing it? So you might be scheduling it, you might be using API actions, for example, from a Lambda function that's scheduled to run on a certain interval. Then the RTO, again, minutes to hours, it depends on the size of the database. These can be cross-region, so you can choose to save that snapshot to a different AWS region. Next, we have read replicas. The RPO is seconds to minutes. Now, it's asynchronous replication here. So there is a little bit of a lag, and it depends. There's something called the replica lag, which is a metric that you can look into, and it really depends on whether you have replicas of replicas. So that can slow things down considerably because there's a bit of a delay asynchronously replicating from the main database to a replica, and then that replica can then replicate to another replica and so on. So you end up with a bit of a lag. RTO again, minutes to hours, depends on the system, but you can bring up a read replica and promote it as a main database if you want to, and that will take a bit of time. It will take maybe 15 minutes to occur. Now, these can be cross-region, so your replica can be in a different region to the main database. We then have multi-AZ. Here, the RPO is milliseconds, so very low because it's synchronous replication. The RTO is within minutes. It's an automated process. The secondary database is automatically, it's also known as a standby, is automatically promoted to be the main database, and it's synchronously replicated, so it already has all the data, so it should be very fast. And multi-AZ is within a region. Let's look at Aurora. Aurora has replicas. The RPO is in the milliseconds. It's asynchronous, so good RPO considering it's asynchronous, and again depends on the replica lag. The RTO, again, we don't really know. It depends on your database. This is single region. If you want to go cross-region, you'll need the MySQL replica. This has an RPO of seconds to minutes, and that depends again on the replica lag. RTO minutes to hours, and these can be cross-region. We've got global database. This has an RPO within the seconds range, and it's asynchronous. RTO again depends, and then you've got cross-region capability for global database. We then have multi-master. RPO is milliseconds. This is synchronous replication. The RTO is seconds because it's automated, and remember it's synchronously replicated, so the data's already there, and this is only within a region. Next database is DynamoDB. With DynamoDB, one option is point-in-time recovery. RPO is around 5 minutes. RTO again depends. Cross-region capability. We've got on-demand backup, which is manual, so the RPO depends on when you actually take the backup and how regularly. The RTO is again minutes to hours, and this is cross-region because you can save the backup across to a different region. We have global tables, which has an RPO in the minutes range, and I believe it's around about 15 minutes, but it can be less, and I've certainly seen it. I think I have seen that documented somewhere around 15 minutes. In reality, when we practice with it, it can be quite a bit faster. The RTO is within minutes, and this can also be cross-region. So that's it for RPO and RTO, and it is really useful to understand this for the exam because questions do come up where you'll need to understand what's possible given a certain scenario. So let's have a look at the DR strategies, and these come from the AWS documentation. So if you look on the left-hand side here, it's blue. These are the lower cost options, and in the red ones on the right-hand side, this is going to be considerably more expensive. So in the cheaper category, we've got simply backup and restore. And this would be for lower priority use cases. Okay, so you're not going to get the best RPO and RTO. It's going to take time to recover. You could lose data. It's going to be cheap. So you wouldn't do this for, critical data, critical systems. And in this case, what's happening is you're taking backups and then you're restoring from backup after a disaster recovery event. Next, we have Pilot Light. So here the data is live, but services are idle. We'll see in a bit more detail shortly what that means. And what happens is you have a minimum of systems running, and when an event happens, a disaster event, then you can start scaling those systems. It's going to be a bit more expensive. After Pilot Light, you've got warm standby. Here, everything is always running, but smaller footprint, so not too many systems, but each application component is running. So this is good for business critical. You do still need to scale after an event happens, so there can be a bit of a delay while your systems scale up to the capacity you might need. And then we've got multi-site active. So here you've got zero downtime, near zero data loss. This is for mission critical systems, so both regions are completely active and accepting traffic at all times. Data's getting replicated, and it's going to cost you quite a bit of money here. So let's look at backup and restore. Here in this diagram, we've got two different regions. We have instances with EBS volumes, we've got S3, and we're simply backing up, and we could be doing a cross-region backup. So then what happens is if a failure occurs, we've got the data somewhere else. So we have the data, of course, we have snapshots of EBS volumes. They go to S3, which is a regional service in terms of that's where the data is stored. So you do need to, copy that cross region. That can happen automatically for you. And then with the file system here, the same thing is happening. We're able to replicate that data. And the same with a database, where the transaction logs are going to S3, and that can also be copied cross-region. The next one is the pilot light. So let's have a look. We've got some grayed out infrastructure here. Okay, so it looks like everything's the same on both sides. We've got our load balancer, we've got Route 53, and we've got active. So all active traffic is being directed to this load balancer here into the application, whereas this is inactive. So nothing is being sent to this load balancer. Then we've got our front-end servers, application servers, and we've got an Aurora database and a replica. We then have another replica across region. And then what will happen in a failure is once these systems are down, Route 53 will start directing traffic to this load balancer. And we need to actually launch these instances. So here it says no instances are running. So we've got our auto scaling group, but it's set to a capacity of 0. Okay, so that needs to change. We need to launch those instances, and those instances will take a few minutes to come up and be ready to serve traffic. So there can be a bit of a downtime here. Next, we've got the warm standby. So note now that only these applications here in this availability zone in the right-hand side are grayed out. So we actually do have some application servers that are running. We've got our Aurora replica. So, and we can see here we've got write forwarding to the primary. So that's really interesting. So what this means is that this replica can serve traffic without actually being promoted to being the main database, because it's write forwarding. So it will be a read replica, but any writes that happen will be forwarded to the primary. Now, if the primary is gone forever, then you can promote it as well, and then it will be the primary database. So here we have a couple of instances running. Of course, we do need to scale using our auto scaling group to bring up some more if we need some more for the traffic, and of course for redundancy within across the two availability zones as well. So that's the warm standby. Lastly, we have the multi-site active. So of course this is going to be an expensive solution because nothing's grayed out, everything is running, and we've swapped now to DynamoDB global tables for the database, which is interesting. Why? Because it is actually multi-master, so you can actually make the writes here, and those writes get actually saved across regions. Now, of course, in the previous diagram, we used Aurora with write forwarding. That's possible as well, but there could be a little bit of a lag on that. So this might be a better solution. And we've got active from Route 53. So it's forwarding traffic to both regions, both of these load balancers, and they have front-end and application servers running as well. So everything's running, and it's going to cost you more, but the RPO and RTO is very good. Both regions are serving traffic at the same time. So there's really no failover happening at all. Now let's have a look at a serverless reference architecture for a multi-region application. And this particular architecture has an RPO of 15 minutes and an RTO of a few seconds. And you can go to this link to learn more about it. And there's actually a CloudFormation template you can use to provision this, and some code which is on GitHub. So this is the document. And if I just look at this particular diagram, we can see here we have two different regions. One is a primary and one is a secondary, so it's for failover. And everything is serverless. On the front end here, we have CloudFront, we've got Cognito, user pools and identity pools, we've got Amplify for the front end UI, and we've got Amazon S3 for some static website code. Then the traffic is going to be directed to the API gateway, which will be a regional endpoint within this region, and it then forwards on the connection information or the request to DynamoDB, and then we have the backend infrastructure. So everything, of course, here is serverless, and we have replication happening using global tables for DynamoDB across regions. So it can fail over extremely quickly if something goes wrong with the primary region. Okay, now let's finish this off with an RDS Disaster Recovery solution. And this is an active-passive DR configuration. And this is the one we're actually going to build in the lab within our live session. So we've got two regions, and on the left-hand side here, we have an auto-scaling group that uses a community AMI. So we've already pre-created the AMI. The AMI is available so you can use it. And then you're going to launch instances from that AMI. We'll have a load balancer in front, and we'll have a main RDS database on the back end. Now we have secrets manager so that the EC2 instances can find a secret, and that secret will have the database connection information so that the instances can connect to the main database here. Now we've then got Route 53, and Route 53 will be forwarding on all connections to the ALB in region A initially. So let's say that's for example.com. Now we'll then provision a read replica for our database. We'll also copy the AMI across to region B. Now we've got asynchronous replication happening for our database. We've got our instance in region B launching from the same AMI, so a copy of it that's been copied across. And we will make a few modifications before we do that. And then we have our application load balancer in region B. So this is our DR solution. And it's active passive, so at the moment the active region is region A. And what's going to happen is we're going to simulate a failover. So our database is going to fail, and what's going to happen is we're going to edit our RDS endpoint in Secrets Manager. That means that our instances over here will now know that they need to connect to this read replica. And of course, we need to also make sure that Route 53 fails over. So we're going to have a primary and a failover, and the failover is going to point to the ALB in region B. So that's going to fail over. Now, example.com is going to get served by the infrastructure in region B. So that's a failover. Now, what are the RPOs and RTOs here? Well, Route 53 doesn't have data, so there's no RPO. Also, our EC2 instances and load balancers don't have any data. So, of course, all that data is being stored in the database, so there's no RPO applicable. The RTO for Route 53 is about 5 minutes. Should be a bit faster. Then we have about 2 to 3 minutes RPO for our read replica. So that's the lag time for asynchronous replication across regions. And how long does it take? Well, I say 15 minutes. It should be within 15 minutes for the read replica to be promoted to being the primary. Now, during that time, there is an outage of that database. So you've got to understand that your RTO can't really be lower than this when you're using RDS.